you sure you understand seasons? Remember those 7 parallels that we learned? The Tropic of Cancer, the Tropic of Capricorn, etc. Well, they each have a significance, right? And they all are attached to a specific day that marks the beginning of the seasons. We're going to understand those today. On average, we're 93 million miles away from the sun. As Earth orbits around the sun, there's a time of the year that we're a little bit closer to the sun and a time of the year that we're a little bit further from the sun. Earth is closest to the sun on January 3rd. We call that day the perihelion. Earth is furthest from the sun on July 4th. We call that day the aphelion. Earth's distance from the sun does not play a role in the seasons. The difference between the aphelion and the perihelion is not enough to cause the seasons. Then what does cause the seasons? Let's list 5 things that cause the seasons. Number 1, Earth is a sphere, or specifically, it is an oblate spheroid. Because it is round, certain places receive direct rays of the sun, and other places don't. That has a huge impact on seasons. Number 2, Earth rotates. It rotates every 24 hours, and because of that rotation, every single day, sun's energy is distributed around the entire planet. Number 3, Earth rotates on its axis tilt of 23.5 degrees. That means that 23.5 degrees north and 23.5 degrees south are the northern and southernmost points to ever get those direct rays of the sun. Number 4, Earth's axis tilt and the North Pole are always tilted toward the North Star, or Polaris. And number 5, Earth revolves. It revolves around the sun every 365 days. And that 1-year path, that revolution, plays a big role in the seasons. This is a diagram of the revolution of Earth around the sun, but let me try to act it out for you. Let's first notice that the Earth is on its axis tilt of 23.5 degrees, and that the North Pole is tilted toward the North Star. Also, notice that in this example, the northern hemisphere is tilted toward the sun, so I know that it is June. Let's complete this revolution. And notice that the North Pole will continue to tilt toward the North Star. So we started in June, now we're moving into September, then into December, and please notice that the southern hemisphere is now tilted toward the sun. What season is it in the southern hemisphere in December? That's when they have their summer. And I'm continuing on. I'm heading into March and back over to June, which means we completed 1 complete revolution. Let's do this again, but this time let's tie in those 7 important lines of latitude. And also, we're going to understand the significance of 4 important dates that mark the beginning of the seasons. Again, the North Pole is tilted toward the North Star, and the Earth is on its axis tilt of 23.5 degrees. Well, cut me some slack. I know I'm not holding it exactly correct, but you get the gist. As we describe the 4 important dates that mark the beginning of the seasons, there's also 4 things that occur on each one of those days. I'd write these down. You got to make sure you feel comfortable with this process. June 21st, we call it summer solstice in the northern hemisphere. The first thing to write down in your list is that the northern hemisphere is tilted toward the sun. Number 2, the direct rays of the sun, those vertical 90-degree rays, they hit the Tropic of Cancer. Remember when we said that the Tropic of Cancer marks the northernmost point to ever get the direct rays of the sun? This is the day that happens. Number 3, the Arctic Circle and everywhere in it gets 24 hours of complete daylight. Remember when we said that the Arctic Circle marks the southernmost point in the northern hemisphere to ever get 24 hours of daylight or darkness? This is the day that it gets 24 hours of complete daylight. Number 4, the Antarctic Circle and everywhere in it gets 24 hours of complete darkness. Remember when we said that the Antarctic Circle marks the northernmost point in the southern hemisphere to ever get 24 hours of daylight or darkness? This is the day that it gets 24 hours of complete darkness. As the northern hemisphere is tilted toward the sun and the direct rays of the sun are hitting the Tropic of Cancer, it makes sense as to why we have summer in June. It makes sense as to why the southern hemisphere has winter in June. You see how they're tilted away from the sun? Also note that the northern hemisphere, we have our longest day of the year on June 21st. The very next day, our amount of daylight is going to get continuously shorter. The days will get continuously shorter all the way until we hit December 21st, when we will have our shortest day of the year. Let's jump to December 21st, our winter solstice. And first notice that the southern hemisphere is now tilted toward the sun. The direct rays are on the Tropic of Capricorn at 23.5 degrees south. Now the Arctic Circle gets 24 hours of total darkness, while the Antarctic Circle gets 24 hours of complete daylight. So let's be clear about what's going on this day. It is summer in the southern hemisphere. It is winter in the northern hemisphere. The southern hemisphere is having their longest day of the year. We in the northern hemisphere are having our shortest day of the year on December 21st. And our days will get progressively longer all the way until we get back to June 21st, our longest day of the year in the northern hemisphere. Also, remember when we said that the Tropic of Capricorn marks the southernmost point to ever get the direct rays of the sun? This is the day that happens. And remember when we said that the Antarctic Circle was the northernmost point in the southern hemisphere to ever get 24 hours of daylight or darkness? This is the day it gets 24 hours of complete daylight. We completed December 21st. Let's revolve back around to September 22nd. In the northern hemisphere, we call September 22nd the fall equinox. Use that word equinox to help you understand some of the things that occur on this day. First, notice that the North Pole continues to face toward Polaris, We could say that neither hemisphere tilts toward the sun. The northern hemisphere doesn't tilt toward the sun, neither does the southern hemisphere. Next, the direct rays of the sun on the equinox are on the equator. Next, the equator gets exactly 12 hours of daylight and 12 hours of darkness. Yes, the equator gets 12 hours of daylight, 12 hours of darkness every day of the year, or pretty dang close to 12 hours and 12 hours. However, on this day, it gets exactly 12 hours of daylight and 12 hours of darkness, while the rest of the planet gets as close as possible to 12 hours of daylight and 12 hours of darkness. On September 22nd, it is fall in the northern hemisphere and it is spring in the southern hemisphere. Okay, let's continue to revolve. It is September. We're going to go into December, and then we're going to wrap back around to March 20th. In the northern hemisphere, we call this day spring equinox. And the things that you listed for our fall equinox, you could list for the spring equinox as well. Neither hemisphere is tilting toward the sun. The direct rays of the sun are on the equator. The equator gets exactly 12 hours of daylight and 12 hours of darkness. And the entire planet gets as close as possible to 12 hours of daylight and 12 hours of darkness. But in March, in the northern hemisphere, we experience spring, and in the southern hemisphere, they experience fall. What's different if the same things are happening? What's different is that we're coming out of winter, which leads us into spring, and in the southern hemisphere, they're coming out of summer, which leads them into fall. That concludes our revolution of Earth around the sun, and I'm hoping you have a better understanding of its relationship to seasons.